So welcome to this session in relation to the enthalpy changes. In this session, we will discuss three problems, and these three problems are, the idea of these problems are frequently appearing in the exams. So the first problem that we will see is when you are given the enthalpy, the bond enthalpy of the component of the reaction and the reactant and products, and then you are asked to predict the enthalpy change of a chemical reaction. Now, this type of problem is straightforward, and you shouldn't be losing marks when you do it. However, the loss of marks comes from different things, and we'll discuss them accordingly. So let's discuss this problem. To start with, the enthalpy change of this chemical reaction. So this is the oxidation of methanol, combustion of methanol or oxidation of methanol. And this basically results in the CO2 and H2O. Okay, so in this case, just fixing the board here. Okay, so in this case, we have the delta H equals to the summation of the reactant minus the summation of the product. The main thing in this case is you need to pay attention to the structure of the molecule so that you count all the bonds correctly. And also you need to pay attention to the coefficients. And you need to do the calculation steps step by step so you don't rush it. So let's start. So here in this case, we have open square bracket, small bracket, and we have 3 times CH. CH is 410 plus. We have 1 OH, so that is 465, close the bracket. And then we have CO, C single bond O, and that is 1 times 336. And also we have 1.5, 500. That is for the O2. Close the bracket. This is minus the products, and that is, you have CO double bond, C double bond O, and you have 2 of them. So here you have basically 805 times 2, plus you have 4 of the OHs. You have 1, 2, 3, 4. So that's 4 times 4, 5, 4, 6, 5. Okay, now in case if you've got an equation written in symbols like this, so it will be 2 moles of water. So basically for the water is, the structure of water is H2O. So here you have 1, 2, and 2 basically times the coefficient 2, then you will be getting 4, as you got here. Okay, now when you solve this problem, take your time and do the calculations correctly. Fine. And in maths, as you know, you need to do the whatever operation within the brackets before anything else. And also you need to do the multiplication and division before the subtraction and addition. So here we have 3 times 410, that is 1,230. 1,430. 200. Plus 465 plus 336 plus 750 minus, here you have 805 times 2, that's 1,610, plus 4 times 465, That's 1,860. So this again equals to, and I'm purposefully doing this. And the reason here is because I'll explain this when I finish the final digit. So if we add all these numbers together, so this will be 1230 plus 465 plus 336 plus 750. That is 2,781 minus, and on the other side we have 1610 plus 1860. That's 3,470. 3,470. So the final answer is minus 2781. The answer will be 689, and negative because this number is negative, kilojoules per mole. Now the thing is, I have done this step by step because I wanted to get correct the summation of the reactants, which is this one, and the summation of the products, which is this one, which is the whole number. And also I wanted to get right the final answer, which is this one, and also the units. Because if the marking scheme is given 1 mark for the summation of the products, 1 mark for the summation of reactant, 1 mark for the final answer, 1 mark for the unit. So basically 4 marks, or maybe 5 marks, and 1 mark to show how you worked out the problem. So basically, you'll be losing 4 marks if you don't get the exact figures, and you'll be getting only 1 mark for all this problem. Okay, so please pay attention and do the problem step by step, and take your time. The second type of problem is when you are presented with data and you are asked to draw a process cycle. So in this case, basically, most of the time, there are one of the two things. It's either you are provided with enthalpy change of formation or enthalpy change of combustion. If you are provided with enthalpy change of formation, then when you draw the cycle should be, the arrows here, they should be pointing upwards. And the reason is because you are basically forming the reactant and forming the products from their elements, their standard state. So basically you are forming this from this, and that's why the arrow is pointing up. Whereas if you are provided with a data for the enthalpy change of combustion, so that means basically you are reacting the reactant and you are reacting the products with oxygen to form the combustion products. And if we are talking about organic compound, so then you are talking about carbon dioxide and water. And in this case, basically, the arrow, they must be pointing downward. And the reason is because, as I said, you are reacting reactants and products with oxygen, and you will be getting reactant products. Okay, so basically, in this type of cycle, whether this one or this one, the enthalpy change here, the enthalpy change of this reaction equals this one, this side, and this side. Fine. So this is when we do the calculation. I'll come to this when we do the calculations in the problem in a second. Okay, so here we have problem. The first problem here is you are presented with the enthalpy change of formation of different compounds, and you are asked to find out the enthalpy of this chemical reaction. So what do you need to do? Now, the first thing is have a look at the chemical reaction. And in your chemical reaction,